All right, so we have this function now. We're going to take the derivative of it and set it equal to 0. So the derivative of this, a prime, remember, anytime you're finding a maximum or minimum, you're going to take the derivative, set it equal to 0, and find your critical numbers. So that is 100 minus 4x. I can solve for x. X equals 25. So they want to know the greatest area that the fence can enclose. So I actually have to answer the question. What's the question? What's the greatest area? So I need to use my area equation. 100 times 25 minus 2 times 25 squared. Uh-oh. Hopefully that is a positive number. Otherwise, we found the minimum. The answer is 1,250 yards squared. Okay? Simple as that. Box your answer. You're set. Let's try another one. So this time we want two positive numbers whose sum is 8 and whose product is a maximum. So what are we maximizing? We are maximizing the product of these numbers. So let's pick two numbers. How about x and y? Okay, so if their sum is 8, remember I want a function in terms of one variable. I'm maximizing the product, but they've given me this piece of information. I want the product, which is xy. I need to use this to get product in terms of one variable. So I'll do x times 8 minus x, or 8x minus x squared. Then take the derivative, set it equal to 0. So p prime is 8 minus 2x, and that equals 0, so x equals 4. All right, finally, I need to find the two numbers, because that's what the question is asking for. So if x equals 4, then y equals 4. Those are my two numbers. You'll notice that squares play a role here. So here, on our rectangle problem, if you split this up into two squares, you'll find out that our maximum was a 25 by 25 square, and then this one is 25 by 25. Okay? 50, yeah. So you kind of, squares play a role here. 4 times 4 is going to be the biggest because that's a square of the number 4. So just some thoughts to keep in the back of your mind. This problem is horrible. Okay? They want you to make an open top cardboard box by cutting squares x inches on a side from each corner of a 12 by 15 inch piece of cardboard and then folding the edges up. Now here's the trick. You've done these already. They've had you find the area, but now we're going to, or found the volume. Now we're going to maximize that volume. How do we do that? So one side was 15, one side was 12. Remember, we're cutting the corners out and then folding it up. A good picture will always help you. Since this is going to be our height, this is always going to be x. Okay, so what is this distance now? It's 15 minus 2x. What's this distance? 12 minus 2x. So can I find the function in terms of one variable? Of course. Volume equals 15, so basically area of the base times height, which is 15 minus 2x times 12 minus 2x times the height, which is x. Now they want us to find the value of x that results in the largest volume, and then find the volume. So I'm going to find the derivative of this. Again, it's going to be easiest if you multiply this out. I know it's gross. 15 times 12 is 180, if I'm not mistaken. I'm going to ignore this x for a little bit, because you'll see that we can get rid of it pretty easily. 15 times negative 2 is negative 30. 12 times negative 2 is negative 24, so it would be negative 54x, and then plus 4x squared. Now, what do I do with this x? Well, I'm just going to multiply everything by x. That's fine. Okay, now I want to find the derivative, set it equal to 0. That is 180 minus 54x plus 12x squared. So I'm going to have to do the quadratic equation or factor in order to find out the solutions. In this case, we'll do the quadratic equation, and the solutions are 2.2087 and 6.7913. So we found two solutions now. Which one's the maximum? Which one is not? Well, that's a tricky question. So here's what we're going to have to do. You're going to have to plug these values in to find your volume, okay? It turns out that this is going to be one of our minimum values, and this guy is going to be our maximum value. So, oh, sorry, I got that wrong. This is our maximum value. Couple of ways to do this. First of all, you can plug these numbers back into your volume, which you already have to do anyways, so I would highly recommend that. And then figure out which one's bigger. That's your maximum. So we're going to say maximum at x equals 2.2087 is, if you plug that into your calculator into this function, you get 177.2341 inches cubed. That, my friends, is problem set 52.